Okay, a 15 kilogram rock is on the edge of a 120-meter cliff. What potential energy does the rock possess relative to the base of the cliff? What is the gravitational force exerted on the rock at this location? So, how do we approach this problem? The big idea here is gravity does two related things here. Potential energy tells you how much the rock has because it's high up. And two, the gravitational force tells you how hard Earth is pulling on it right now. They're connected, but not necessarily the same thing. So let's look at gravitational potential energy. Intuitively, if the rock falls, gravity can convert its height into motion. The higher it is, the more energy it has stored. So the formula for this, U is equal to mgh, which goes to 15 times 9.8 times 120, which is equal to 17,640 joules. So the potential energy is 1.76 times 10 to the 4th joules. Now, the second part is gravitational force on the rock. Intuition, this is just the weight of the rock, how hard Earth pulls downward. The formula is equal to F equals ma, but it's mg because of gravity. So the math shows F is equal to 15 times 9.8, which is equal to 147. Now, g is a negative, right, because it's a negative acceleration. So you don't necessarily have to put negative here, but as long as you know that it's going to be negative here, then that's good. But if you didn't, you can put a negative here because gravity is a negative force. Well, it's negative, right, because it's pulling downward. So anyways, the answer is 147 newtons downward. You can say that. And that is the answer. Now, potential energy depends on height. Gravitational force does not. It's the same whether the rock is on the cliff or on the ground. The rock has a lot of energy stored, but gravity is pulling on it just as hard as anywhere else. So that's all that matters.